All right, today we're going to look at handout 3 in our packet. So go ahead and flip to that third page. We are looking at interior angles of triangles. So the 3 angles that are inside our triangle. All right, and we know that the sum of the 3 interior angles of any triangle will always equal 180 degrees. Meaning when we add up all 3 angles in any triangle, we'll always get 180 degrees back. In questions 1 and 2, it says use what you know about parallel lines cut by a transversal to help you prove that the sum of the interior angles of a triangle is always 180 degrees. So we're going to use our knowledge of having parallel lines leading to congruent alternate interior, alternate exterior, congruent corresponding angles to help us prove why the 3 angles in a triangle are always 180 degrees. So in problem 1, it tells us that line A is parallel to line B, which now tells us that all of those angle relationships we know will apply to either be congruent or supplementary. Our job is to prove that the sum of the 3 interior angles in this triangle will equal 180. So the first thing we know is going to be what angle 1 measures. Because if we were to extend this transversal between our parallel lines, we could see that angle 1 and this 62-degree angle are alternate interior angles and therefore congruent. So we're going to go ahead and say 62 degrees because angle 1 and angle CDE are alternate interior angles and congruent. We're going to do a very similar process just on the other side. We still have our parallel lines here, but this time we're going to look at this transversal in green. Now when we look at this, we can see angle 3 and angle 35 are alternate interior angles as well. So we can go ahead and say that these 2 angles must be congruent, and this must be at 35 degrees. So our explanation is going to be pretty similar to what we just wrote, but now we are talking about angle 3 and angle CED. So angle 3 and angle CED are alternate interior angles and congruent. So we could go ahead and write in those new angle measures that we know. We know this angle is 35 degrees and this angle is 62 degrees. And the last thing we have to figure out is what this angle 2 is. So because we have a straight line right here, and that line is formed by angle 1, angle 2, and angle 3 all added up, all we have to do is 180 minus part of it, which is 62, minus another part, which is 35, and that will give us back whatever number angle 2 will be congruent to, which is 83 degrees. All right, and our reason here is because angle 1 plus angle 2 plus angle 3 equal 180 degrees, since they form a straight angle. our conclusion here says the sum of the interior angles of a triangle is 180 degrees because by proving that angle 2 is 83 degrees, we can check the total sum of the angles in the triangle. All right, so if we were to measure these up, 62 plus 35 plus 83 equals 180. And in problem 2, we are told that line C is parallel to line D and that lines E and F are both transversals. So, one thing we know is that angle 1 and angle 2 and angle 3 together will add up to 180 because they form that straight line right there. If we were to combine each of these sections, we get that straight line or that straight angle in green. So our reason here is these 3 angles form a straight angle or straight line, which is 180 degrees. Next up, it's asking us to look at angle 2. So I'm going to go ahead and highlight the parallel lines and the transversal that cuts angle 2. So when we look at this setup, we can see that angle 2 is related to angle 4 because they are both alternate interior angles. Because lines C and D are parallel, we know that our alternate interior angles are congruent. So we're going to say angle 2 and angle 4 are alternate interior angles and congruent. All right, now when we look at these same parallel lines, but when we look at this transversal, we see a little bit about angle 1 and angle 5. Because when we look in that intersection of both of those meeting points, we can see that our given angle 1 and angle 5 are both in that top left corner. We can say that they're in the same matching corner or that they are corresponding angles. Because our lines are parallel, we know that corresponding angles are congruent. So we can say that angle 1 is equal to angle 5 because angle 1 and angle 5 are corresponding angles and congruent. So we got a conclusion which says the sum of the interior angles in a triangle is 180 degrees because if angle 1 plus angle 2 plus angle 3 is 180, and we can fairly substitute, make some replacements, Angle 2 can be switched with angle 4. And angle 1 can be switched with angle 5. We now have angle 5, angle 4, and we'll keep everything else the same. Plus angle 3 and still equal to 180 degrees. And so that's how we have shown that the three angles inside our triangle, angle 3, 4, and 5, which are all listed right here, will equal 180 degrees. We're going to do one more problem. So go ahead and flip over to the back of your packet now to get to problem 3. It says, use what you know about angle relationships to answer question number 3. It says line C is parallel to line D. What is the measure of angle 5 if angle 2 is 48 degrees? Okay. And angle 3 is 93. Explain how you found your answer. All right, so we could go ahead and highlight the questions asking us, what is the measure of angle 5? Well, there are a couple ways that we can get to it. One way is by emphasizing that we have our parallel lines. We know our transversal will give us those angle relationships. So if we look at the relationship between angle 2 and angle 4, we could go ahead and say angle 2 and angle 4 have the same measure because they are alternate interior angles. So now we know that angle 4 is also 48 degrees. So now when we look in this triangle, we know this angle, we know this angle. The only thing left is angle 5, which is what we are asked to find. So you could say that angle 5 is equal to 180 minus 93 and minus 48. And when we go ahead and calculate that, we get back 39 degrees. And that all comes from the new idea today that all three angles in a triangle add up to 180 degrees.